So we're back again and continue with the 802.1 X standard. So because there must be a method to ensure that others with wireless NICs can't access resources on our wireless network, the 802.1x standard is defining a process of authenticating users on the network. So when physical access control is more difficult to enforce than on the wired LAN aspect. So we use these basic concepts, which we'll go over now in some detail. So point-to-point protocol is one way. In many of these internet service providers or ISPs, they use point-to-point protocol to connect dial-up or DSL users. And PPP handles authentication and by username and password. And it's going to include password authentication protocol known as PAP. It can use EAP or the Extensible Authentication Protocol, and it can even use CHAP, the Challenge Handshake Authentication Protocol. In fact, CHAP is most commonly used. The TCP/IP also relies on point-to-point communication, meaning that communications move from one host computer to another with a predefined network boundary, right? So the key advantage of PPP is that EAP that I mentioned, the Extensible Protocol Suite. So EAP stands for Extensible Authentication Protocol, as many of you already know. EAP is a protocol for wireless and wired networks, one big advantage, and it expands on authentication methods used by point-to-point protocol, or PPP, which I said was a protocol that we often use when connecting a computer to the internet. So the authentication server is going to ask the access point for proof of the validity of the ID, right? We'll talk more on EAP in a minute. So over the years, new protocols have been added to the suite over time, which is great. And so PPP's success really has even led to the development of other derivative PPPs like Ethernet, PPP over Ethernet, or is this PPPoE, or this PPP over ATM, right? Which is PPPoA, right? And so these actually layer PPP over existing data link layer technologies, which I think is very interesting. And I hope you enjoyed that conversation too. I know I did. So EAP, which is what I've been trying to get to, I love. Extensible Authentication Protocol. It's an enhancement to the PPP. It was designed to allow a company to select its authentication method. I mentioned Windows, for example. Kerberos authentication uses EAP, right, to authenticate to an access point. And it contains an X.509 information. And that's going to identify the owner, the certification authority, and the owner's public key, right? We're getting now into some cryptology, which again is chapter 12, right? The next chapter. So we're kind of getting ahead of ourselves, but it's an important part of that process, right? So for example, right now, if you wanted, you could go to paypal.com. It would www.paypal.com. It's going to redirect you to a secure HTTPS URL where you can click on the padlock on the top left and view the certificates. You might want to do that. In fact, I'll add that to the slide now. Okay, so you can see that I have added the instructions there. Take your time, pause the video, go do that. I think it's an interesting and worthwhile venture from an educational perspective. So this EAP, this Extensible Authentication Protocol, it's this general framework for securing authentication traffic. It encapsulates the traffic, right, in that envelope. And it doesn't specify whether PKI is used, the public key infrastructure, that's the cryptography that we'll talk about in chapter 12, but PKI is one way that EAP is used. Like I said, one of the advantages to EAP for securing authentication traffic is that it can be done with EAP over EAP TLS or EAP using PKI or EAP fast or other variants, right? We talked about EAP is connecting a device using network authentication framework that supports this. For example, I mentioned PKI certificates, passwords, smart cards, right? So wireless networks that support WPA2, for example, commonly provide multiple EAP options, and they are using radius authentication to support that, right? So the computer hardwired or a wireless access point could reach out to this authentication network, right? Which is going to reach then out before it allows you access to a radius server who's going to take care of that authentication and pass back yes, allowed. Okay, very interesting. Now, EAP, the following EAP methods can be used to improve security on a wireless network, right? I mentioned there were variants of it, and I put on there's a few variances I'm going to talk about, but on the right there are some others that I highlighted, including LEAP, PEEP, EAP-FAST, EAP-TLS, and EAP-TLS. So EAP-TLS requires assigning a client and the server digital certificates that are assigned by a certification authority that both parties trust, right? This is really Chapter 12 conversation, but many of you have had these experiences already. So the CA can be a commercial company, right? GoDaddy is a commercial certification authority. They're going to charge a fee. And the network administrator then is going to configure the server with these certificates, right? But you can also self-sign a certification authority, which many big companies do. So both the server and the client authenticate mutually to each other. In addition, two servers will require the client to prove that they are who they are. Right? And clients also want servers, don't we, to verify their identity, right? PEEP uses TLS to authenticate the server to the client, but not the client to the server. So that's, it's limited. It's an older version. And that's PEEP is that protected EAP, it's called. There's also LEAP, which is lightweight EAP. PEEP is more secure between the two of them, I believe. And both of these implementations require a server certificate on that radius server that in the picture I showed you in the last slide, right? So, okay, that's interesting. There's another picture of it, of EAP. Figure 11-8 from the book. So an unauthenticated client, which is called the supplicant, right? You haven't been authenticated yet, attempts to connect to the access point functioning as the authenticator. So the AP is actually going to respond by enabling a port that passes only EAP packets to the radius server on the wired network. So your access point is giving access to the wired network through a port only for the access to the authentication server. And the AP is going to block all other traffic until the radius server returns an authentication, authenticates the supplicant. After the radius server authenticates the supplicant, it gives that supplicant access to the network via the access point, right? And so until EAP and 802.1x were used on a wireless LAN, a device, it was difficult to authenticate a user on the wireless LAN. Therefore, if the computer was stolen, the thief could connect actually to your wireless network. So very interesting. Radius Federation would be my final point here. It's that group of Radius servers that assist with network roaming and will validate login credentials of a user belonging to another Radius network, right? So it's very interesting. Okay. Most wireless access points, they do come with the ability to enable one of 4 wireless encryption standards. So most of them will be able to encrypt wirelessly WEP using WPA, which is Wi-Fi protected access, WPA2, or now even WPA3. So again, WEP was the first encryption algorithm in the 802.11 standard. And the main goal, it had one main goal, which was to prevent hackers from snooping wireless data as it was being transmitted between the client and the access point. And so from its inception, it did lack some strength necessary to meet this goal. WEP, it used RC4, which is a stream cipher. We'll talk about that in chapter 12. Basically, it just, we're about encrypting the data that's traversing the wireless network as it gets to the wired. Again, many vulnerabilities in the older approaches, right? So WPA was developed after that, and then WPA2. So WPA was a replacement for WEP, right? But it was also soon found to have cryptographic weaknesses. Now, WPA2 used TKIP, or Temporal Key Integrity Protocol, to encrypt. And what I love is that it was a per packet key mixing, right? It would encrypt per packet. I think that was great. But smarter people than me were able to figure out how to hack that, right? So WPA did improve on encryption using the TKIP. It was a positive step forward. But again, people begin to think, this is inviolable, and it isn't. It's violable for sure. So we ended up with then WPA2, right, which is another positive approach. Here is a one-slide summary of kind of the WEP, WPA, WPA2, and WPA3. I'd say pause the video at this point, read through it, make sure that you're comfortable with it. It's really largely a summary of everything we've talked about. But you'll notice from WEP, which was a stream cipher and a 64 or 128-bit keys, that now doing to WPA2 was a 256-bit keys. You can see the strengthening. In WPA2, using AES algorithm for even stronger encryption. Again, that's chapter 12. Now, the Wi-Fi protected setup, WPS, this is a wireless authentication that the user simply presses a button on the router, and the WPS-enabled devices, it's going to pair with the router, right? And it's usually a simple process of pressing the button on the router, and the WPS, it pairs, right? And so the issue is that it allows an attacker to gain access to your network remotely without knowing the WPA2 password. So this standard was created to allow users easily add devices to a wireless network, and it eliminates the need for users to enter a password, right? But it gives the attacker some advantages. Now, war driving is a concept that we must incorporate around this. This is the act of discovering unprotected wireless networks by using a laptop outside of an office building. Hackers, they just drive around. That's called war driving. They drive around with inexpensive hardware and software, and it enables them to detect the access points that haven't been secured. Surprisingly, some access points have no passwords or security measures. Hence our role as security testers. While driving isn't illegal, I want to also note it's been expanded to war flying, where people actually use drones in this capacity. So here's a quick slide on how it works. I'll come back and start here and finish it up.